So this is our multivariable second derivative test. So this is like the second derivative test in one variable. It tells us if something is a max or a min. How does it work? Okay, so suppose that we've got some critical point, some point where the derivatives vanish. Okay, and now we look at the determinant of the Hessian, and we notice some behavior here. So if it's a cup or an inverse cup, the determinant will be positive. If it's a saddle, then the determinant is negative. Okay. So if we've got negative determinant, then we're in the saddle type situation. If the determinant is positive and the second derivative in x is positive, then we're in this case. Xy is a minimum. The second, or if the Hessian is positive, second derivative negative, and we get a max. Okay, so these two conclusions are very similar to the single variable case, right? If we're in one variable and we've got positive second derivative, then we're a min. If we're in one variable and we have negative second derivative, then we're a max. Yeah?
What do you mean by saddle point?
One of these guys. So it's neither a min nor a max. So something where, so hold out your hand like this. Hold out your hand sort of in a cup shape, like a U. Notice that where your thumb connects to your hand is neither a min nor a max, right? If I travel in this direction, I increase. And if I travel in this direction, then I decrease. Okay, so that's a naturally occurring example of a saddle point. So when I say a saddle point, I mean something where in one direction you're decreasing, and in the other direction you're increasing. Yep.
Can we also use Fyy, or does it have to be strictly Fxx or the second min-max?
Right. So it's a nice theorem that you can also do this with Fyy. Yeah. Thanks for checking.
Is it possible that they're ever both less than 0?
That both of these are less than 0. So that this is negative and this is negative? No, that can't come up. Yep.
So like the normal second derivative test, are they inconclusive? They're both 0?
Yes. Yeah. So if the determinant is 0 or this first derivative is 0, then you get no conclusion. Yeah. Good thing to check. Yeah.
Because we have only second degree functions in all the examples, then our Hessian matrix is constant throughout the entire any point in the function, right?
Sorry, come again?
It's like if you had a higher order function, like a third degree function, and then you
Yeah.
But because you only have constants in your Hessian matrices.
Yeah, so here our Hessians are constant. We'll see in a moment examples where they're non-constant.
Okay, but so what does this multivariable derivative test tell you if your Hessian matrices are constant?
Aha, right. So you plug in this critical point, you take this critical point, plug it in here, and now you've got some numbers to work with.
You already, even before you know the point, you know that the determinant is not going to be 0, right?
That's not guaranteed. The determinant could be 0.
I mean, for these matrices.
For these ones,
Yeah.
yes. Yeah, here you, yeah. Sweet. Yes?
So what if we have more than 2 variables?
Aha, nice. What if we have 5 variables or something? Right, so today we'll focus on the 2 variable case, and we'll generalize later in the course to 5 variables or something. Yeah, that's a good question, but we'll get there. Nice.